We're now going to look into a problem where we use a z-value in finding the random variable x given an area or a probability. So in the previous problems, we were given the value of the random variable of a normal distribution, and we had to find the probabilities. In this situation, we're given a probability and we need to find x. So Leighton Tire and Rubber Company wishes to set a minimum mileage guarantee on its new MX100 tire. Tests reveal the mean mileage of 67,900 with a standard deviation of 2,050 miles, and that the distribution of miles follows the normal probability distribution. Leighton wants to set the minimum guaranteed mileage so that no more than 4% of the tires will have to be replaced. What minimum guaranteed mileage should Leighton announce? We summarize the given information in the problem and represent them in the normal curve as shown on the slide. The item of interest is the value of x, which is the dashed red circle. The area to the left of x is 0.04, the proportion of the tires that will not last beyond the time period x and will need to be replaced. The center of the distribution, 67,900, is the population mean, which we designate as mu. The population standard deviation, sigma, is 2,050. In the next slide, we show the procedure for obtaining the value of the unknown x. Since we know the distribution of the variable x follows the normal distribution, to find the value of the unknown x, we use the formula listed here on this slide. Since we know the area below this unknown x to be 0.04, we use this information to find the value of z using the standard normal distribution table. Shown on the slide is a portion of the standard normal distribution table. Note that this table shows the upper half of the distribution. So recall in the previous slide that the area we are interested in is on the lower half of the distribution. Can we still use this table? The answer is yes. Remember that one of the characteristics of a normal distribution is its symmetry around the mean. So the left tail area of 0.04 as depicted in the figure in the prior slide is actually exactly the same as the 0.04 right tail area of the distribution. To obtain the z-value such that the area beyond it is 0.04, we locate in the body of the table the area closest to 0.4600. Why 0.4600? Well, remember that the areas represented in this table are the areas from z equals 0 to some positive z-value. Hence, 0.4600 is the area between mu and x found by subtracting 0.04 from 0.5. In the table, the closest area to 0.4600 is 0.4599. This is the equivalent to a z-score of 1.75. But because the unknown x value is to the left of the mean, the corresponding z-value is actually negative 1.75. Another way of converting the probability of 0.04 into a z-score is by using an Excel function. Okay, once we have obtained the z-value, there will only be one unknown value in the formula, x. So we continue on the next slide about how the unknown x value is finally obtained. Using the z formula, we substitute negative 1.75 into z, 67,900 into mu, and 2,050 into sigma. At this point, the equation only shows one unknown value of x. So by solving using basic algebra, we find out that the value of x is 64,312. So Leighton can advertise that it will replace for free any tire that wears out before it reaches 64,312 miles. And the company will know that only 4% of the tires will be replaced under this plan. If you're using Excel, then the most direct way to obtain the answer to the problem is by using this Excel function equal NORMINV. Note that this function does not have the S, which is distinguishes it from another function. So on any Excel worksheet cell, you're going to type this information in, and you'll get an answer of 64,311.09.